So what is up, guys? Welcome back. In this tutorial we're going to get a basic understanding of fine-tuning OpenAI's LLM models. This fine-tuning is not a typical LoRA or Quora like fine-tuning. This is actually going to basically fine-tune our like actual API or actual OpenAI models. So let's see this thing in action. So yeah, this is actually the official page that you can see on the screen, that you can, basically most of the theoretical part is going to be mentioned on this page, so you can read. There's also another page that they provide in which they specifically go and talk about the code aspects. So yeah, if I show you guys here, this is the the page on which you get to see the codes, right? And they talk obviously about the parameters and some things like things related to API as well. But as for the theory and those kind of things are concerned, it's better to go with this document. This is where you can get most of the idea. And obviously, as I said before, it's not a low rank adaptation, LoRA or like those kind of technique. This is actually going and training model over multiple, let's say, epochs. Okay, so let's start with this thing. I've created, by the way, a small presentation. So let's start with this. What are the benefits of using fine-tuning? Let's talk about that. So obviously it would give you higher quality results. In this case, you are going to basically alter the behavior of the chat model. So obviously you're going to get a higher quality result than just regular prompting. Then you could train your model on more examples. That's another benefit as well. Usually in prompting, you're fixed with the context window that you can provide. And because of that, you cannot provide more than the examples more than that. But in this case, you can provide more examples and you can train your model on those examples, and that way you could have a better model as well, right? Other than this, if you keep on giving, let's say, longer prompts, in that case you would be incurring a lot of cost. The reason being you're using a lot of context, a lot of you're using basically a lot of tokens that are taking chunk of the context window. And in that case, you would be charged high, as I said before. So if you have a fine-tuned model, in that case, you can give smaller prompts, and that way you could have much better result as well, with obviously lower cost as well. Sometimes fine-tuned models are also smaller in size, and this is the reason you could get lower latency request as well. Obviously, when you stream, whenever you're working with streaming data, you would have issues with latency. In that case, to get lower latency request, you can do fine-tuning instead of giving prompts as well. Okay, when to use fine-tuning? So you can use fine-tuning when you want to completely change the style or tone or maybe the format in which you're getting the output, and other qualitative aspect. So remember the word qualitative, because this is important. It's not quantitative. Let's say if you have tons of documents, like 1,000 or 10 million documents, and you're trying to fine-tune a model on those documents, in that case fine-tuning may not be a good solution. In that case, you can go for something like a RAG, which we're going to talk in further tutorials. But yeah, in this case, quantitative, this is a very important word. To change the qualitative, to change qualitative aspect, you can use fine-tuning. This would improve your ability at producing a desired output. Obviously, you could also, by the way, use fine-tuning when you have a domain-specific custom data as well. Correcting failures to follow complex prompts. So whenever obviously, if something's coming, if you're getting your desired output by doing complex prompts on a regular model, then in that case, and you can do much better if you do fine-tuning. And if the model fails, then in that case, those failures can also be overcome using fine-tuning as well. A lot of these times, whenever there are many edge cases, in those specific edge cases, your model would fail because it might have a very generalized knowledge. In that case, fine-tuning could be a really good solution. Performing a new skill or task that's hard to articulate in a prompt. So in this case, when it's hard to articulate and write it in a prompt, obviously you can use fine-tuning. When not to use, when not to use fine-tuning. Obviously, whenever there are cases in which if you give right prompts, then results can be improved. In that case, it's better to go with those prompting than doing a whole fine-tuning. And the reason being, as you can see, the second point, which says iterating over feedback loop is faster when you do prompting, and when you go with fine tuning, then in that case it's much much like it's not that faster. So what's this iterating over feedback loop? Basically, let's say whenever you have a training data and you train your model, you let's say did fine tuning, and let's say after doing fine tuning you realize that the model isn't performing as expected. Then in that case you would go ahead, maybe get more training examples, or maybe you would train the model for more epochs, and then you would change those hyperparameters and stuff. In all of this case, it's going to take a lot of time, and every single time you get new data, every single time you get new examples on which your model is failing, you would probably go and do a retraining, and you would do a fine tuning more and more. So in this case, this whole process in which you need to create examples, training examples, do a fine tuning, and change parameters, and do like this whole feedback loop, it's much faster when much slower, and it would take much longer time when you do fine tuning. However, if you do this exact same thing with prompting, with the right type of prompting, then in that case that that feedback loop would be much faster, because all you have to do is just change and add more details into those prompts, right? So it's better to go with right type of prompting if you can do that. And yeah, because if a feedback loop is something that's critical to you for your, let's say, project, in that case it's better to go with the right prompts and not with fine tuning as well, right? This is the data format, training data format, and actually if I show you guys on their page, they are showing us, let me just show you guys in here. Okay, this is better in this way rather than watching this whole chunk of text. Okay, let's see. So basically, the way in which you provide training data set is in this format. And this is the format here that you must follow. By the way, you can only provide, according to this guide, you need to provide at least 10 examples. Like that's the limit. Actually, let me find that part. Couldn't seem to find. But basically, you need to provide at least 10 examples. That's the minimum that you can provide. And the model would start to show you good performance if you provide like somewhere 50 to 100 examples. If your number of examples are less than that, then you might not see any big benefits of doing this whole training. So as you can see, they said that at least 10 examples to do a training, and you can do 50 to 100 examples. That in that range you would get a good results with some of their models. They recommend starting with 50 examples. That way it's better. And what they also say is there are only few models that you cannot fine tune all of their models. You can only fine tune these models. So it's GPT-4o mini, which is trained, I believe, on until this date, which they recommend it's better to go with this model. Then you can fine tune 3.5 turbo, and then baggage, DaVinci, and only these models. You cannot go with their other models like text to speech or some of the some other models as well. They in general they recommend GPT-4o mini to be the best model to get really good performance, to have good cost, lower cost, and the ease of use, because of it might have better latency as well. So that's what they say. But coming back to this example format, this is the type of format that they expect us to provide. If you remember, this is the same type of format that we used when we were giving our if you guys remember, when we were giving our our actual prompts. So in our actual prompt, we used to have a system level prompt, which was something like this, and then after that we were having a user level prompt, which is also like this, and then after that we were having a assistant level prompt, which was basically a type of a reply that we were getting from the from the model. So in this case, let's say what they want to do in this example is they want the model to behave a little sarcastic. So they say that Merv is a factual chatbot that is also sarcastic, and they have given this as a system level prompt. And then they are asking some questions, and they want the model to answer, right? So one of the questions they have asked is, what is the capital of France? Okay, and the model would reply that Paris, as if everybody doesn't know that already. So that's obviously a little bit of sarcasm there, I guess. Then if a user asks who wrote Romeo and Juliet, and they say, oh, just some guy named William Shakespeare. Ever heard of him? So you could see these answers are still a little bit sarcastic, and that's what they are trying to do. They are trying to make this model to behave a little bit sarcastic, and that's why they have given this as an example. Now you could also have an additional parameter called weight. This would be used in a case in which you don't want that prompt to be considered. So if you don't want the prompt to be considered, you would give the weight to be 0, and if you want that prompt to be considered, then you will give it 1. So let's say if you are dealing with a regular chatbot, and you have set this as the same thing as a system level prompt, and then you're going ahead and you're asking a question, the same question, what is the capital of France, and the model will reply to you with Paris. Okay, but you could see here we have set weight equals to 0. And the benefit in this case that you would get is that whenever the model would start training, it would not consider this prompt. Okay, then you go ahead and you ask this question: can you be more sarcastic? And the model would reply the same thing, Paris, as if everyone doesn't know that already. And you would give weight here as 1 because you want this answer to be considered and not the previous one. So you could see what's happening. You're asking question and you're giving weight to equals to 0 to the questions that you don't want to be considered, and then you're giving weight to be equal to 1 in the question for the prompts that you do want to be considered. So this is an example of one data point in the training set, and you need at least 50 of these, at least 10 of these to start the training, and you could get better results if you have 50 of these. They also, by the way, provide I believe a data checking format. So if you have written your data in this way and you just need to basically pass this into this thing. Yeah, so they do provide TIT token and like some other things. Basically they say that it's better to have your whole training data. You just need to validate if it is in the correct format or not. If you do that way, during the training phase it won't give you any error. And the benefit of that is that usually training would be it would have some sort of cost. So if you first validate, it's better to make use of the cost that you would be incurred, right? If your data is not validated and it's not in the correct format, training would start maybe and it might fail, and you would be incurred cost for that training part, right? So that's something that they say. They also recommend us to divide our data into train and test splits, so that obviously we can do testing, and we can validate our results, and we can see what are the ways we can improve them. There's also one more thing that's important as well to understand. Actually, let me show you guys this thing. Okay, so we already talked about having at least 10 examples, and I've said that you need somewhere 50 to 100 training examples to do a better thing, right? To perform well, right? Train and test splits, I've already talked about it. You need, if you have them, then that's better, and I would say it's better to have them in general. Don't go for training if you don't have a test split. All right. Check token limits for training example max length. Okay, this is important. So usually whenever you give any input to a chat model, it would have an inference context limit or inference context length, right? Your input cannot have more tokens than this thing, right? For example, for this model, you cannot give more tokens than this thing, right? However, the limit changes when you want to do training. So as you can see for GPT 4o mini, the limit was this for regular context length. Let's say just a regular inference type of work. However, it's almost half for this case, in which you need to in which you need to do training. And you could see the same thing goes there are different limits for other models as well, for example this model as well. So that's the case. So you need to check if you have a correct training limit, training length, and once you have that, once your prompts are within that limit, then it should be fine. Well, the next thing is you need to count the number of tokens. So how do you know if your training data has tokens that's less than this? In that case, they actually have OpenAI actually provides a tick token, I believe. Yeah, tick token is a open source library that OpenAI itself provides, and this is the library that's used to basically tokenize your documents or your sentences into tokens, right? And you can use this library to find out how many tokens are going to be used from the text that you're going to provide. So yeah, it's better to use that. once you do that, once you have your tokens, once your format is validated, once you have everything fine, you can then go ahead and calculate the cost. So this is how the cost would be calculated for your the whole training. So it would be base training cost token, 1 million input token. So this would be something that you would find on the pricing page, right? So it would be base training cost. You just divide that with 1 million, and then multiply that number with the number of tokens in the input file. So this value, number of tokens, you would get it obviously from this thing, tick token, from there. And number of epochs would be something that you would set as a hyperparameter during the fine tuning part, right? So if you do that, then you would get your cost in here. However, OpenAI has some models that they give actually for free for us to you can do by yourself. So GPT-4o mini is free to fine tune starting today through September 23rd, 2024. This means every organization will get 2 million tokens in every 24 hours to train the model, and any overcharge will be charged at $3 per 1 million tokens. So if you're watching this video somewhere in the future, then there may be a chance in which you might get a free model. In that case, your training might be completely free as well. But yeah, do check. And this is the formula that I was saying. They have explained that for training 100,000 tokens over 3 epochs, the estimated cost would be this thing, and it would be this thing for this model, right? So yeah, the free period obviously ends September 23. Right now I'm recording this in the month of July, so we have 2 months from here until this thing gets paid. But yeah, this is how much you would be charged later on, right? Yeah, going further, let's see what we have. Okay, there are some important questions, like I've just listed 2, but you can find more FAQs that on their official page. And like honestly, some of these questions may not be that important to you if you're just learning these things, but some of them are important for developers. But these are 2 questions that are important to you for learning. And interestingly, these questions could also be asked, let's say if you're preparing for an interview, this question could also be asked. And the first one is very important. And this is actually something even I got to learn today. So when can I use fine tuning versus when can I use an embedding or a retrieval augmented generation? Although I have not talked about retrieval augmented generation in this video or in this course throughout, I, by the way, already have a video that I've made. It's a small project that I've made in which I've created this thing, RAG, retrieval augmented generation. And I've used GCP infrastructure. I've used Gemini API as well in that. But in general, like RAG would be used in the cases in which when you have a lot of documents, like 1,000 or maybe like 10,000, sometimes maybe like 100,000 documents. And in that case, what we would be doing is whenever a user would submit a query, we would go and find similar documents to like in those 10,000, let's say, documents. We would find like 5 to 10 similar documents in those 10,000 documents, and we would take them. And then from there, we would provide those retrieved documents from those 5 to 10 retrieved documents and the query to the model. And we would say to the model that, give me answer of this query based on, based on these retrieved documents, like based on this context. And from there, the model will give you an answer. We might do, by the way, this RAG in coming tutorials, but so far I've not talked about them much in details. But yeah, you can find a project on my, on my YouTube, to do this thing. So the question is, when can I use a fine tuning and when can I use a retrieved augmented generation? So retrieve augmented generation would be used when you have, as I said, when you have tons and tons of documents. And fine tuning would be used when you want to completely change the behavior, the style, the tone of the model in itself. Whenever you have your model to behave in a specific way, in that case you can use fine tuning. However, let's say if you want to have your model known lots of data that it was not trained on, and in that case fine tuning may not be a good idea. You might go with retrieval augmented generation, in which you can have those 10,000 documents, and that should be fine. The second question is, can I fine tune a model? Can I continue fine tuning a model that's already been fine tuned? The answer is obviously yes. And this would be an interesting part. A lot of this time, if you, let's say, work in an industry, there you might come across a situation in which your type of data, maybe your data might drift. You might have different changes in your data. In that case, if you have a model that's already fine-tuned onto your data, and let's say your data changes, there is some sort of I don't know, some sort of drift or some sort of difference in the data, and you start to see the model's performance is starting to degrade, then in that case you can go ahead and fine-tune your model again. You can actually fine-tune the fine-tuned model, so that way your model would align to the new coming data. And a lot of companies these days, they also have something called as continuous training pipeline. So basically every week, whenever new data comes, the model would go ahead and continuously train itself, and it would find the best hyperparameters and other things by itself, and then it would stay up to date with the new type of data that it's always getting. So this way you could have a model that keeps on training, like, I don't know, every few weeks. And you could also OpenAI also provides you checkpoints, so you can always go back to the model that was before, and yeah, you could use that model as well. If, let's say, if you did a fine-tuning and the results are not as good as you expected, then in that case you can go back to the previous fine-tuned model. So that should also be fine. Now, so far this was like in general theory. In the next tutorial, we're just going to start with the complete project. So it would also obviously we would do the coding, but we would learn coding while we do the project. And it would be a simple project in which we'll be doing fine-tuning. There's also another project that OpenAI provides that you can also refer to and do it by yourself if you want to. However, for this you might need some data that you can generate using like some external things. So that's the only problem. Otherwise, we might have done this project in this tutorial. But that's the issue. But yeah, you can refer to this code if you want to. But in next tutorial, we're going to have our own project that we're going to perform. And it's going to be, again, as I said, about fine-tuning, and we will learn coding while we do that project. So see you guys in the next tutorial. Thank you so much for watching. Have a good one.